Right now, at this very moment, you feel significant. You feel real, substantial, important. You feel like you occupy meaningful space in the universe. Like you and your planet, Earth, matter in the grand scheme of things. You're wrong. Completely, utterly, cosmically wrong. Earth, the planet you think is enormous. The world that contains every human who has ever lived. Every civilization that has ever risen and fallen. Every mountain range, every ocean, every city is so incomprehensibly, impossibly small that it might as well not exist. And I can prove it. With math, with comparisons, with visualizations that will systematically dissolve your sense of importance until there's nothing left. By the end of this video, Earth will be smaller than a single pixel on your screen. And that's not metaphor. That's not poetic exaggeration. That's math. We're going to zoom out, step by step, starting with Earth compared to other planets, then to the Sun, then to other stars, then to the galaxy, then to the observable universe, then beyond. And at each step, Earth will shrink. Your sense of scale will break. Your intuition will fail. The numbers will stop meaning anything. But here's what's strange. Here's what makes this journey worth taking. Understanding how small you are will actually make you feel more significant, not less. I know that sounds impossible, contradictory, but stay with me. Because the path from cosmic insignificance to cosmic meaning runs through one uncomfortable truth. You need to confront how small Earth really is. So let's begin. Before we zoom out, we need to understand why Earth feels big in the first place. It's a cognitive illusion, a trick your brain plays on you because you have no frame of reference. Think about when you were a child. Your neighborhood felt enormous. Walking to school seemed like an epic journey. Your house was a vast domain with endless rooms to explore. Then you grew up. You got a car. You traveled. And suddenly, that neighborhood became small. You could drive across it in 5 minutes. Your childhood home became tiny. Just a few rooms, nothing special. But you can't do that with Earth. You can't grow up and leave the planet to gain perspective. Earth is still the entire world to you. It's all you've ever known. Every map you've ever seen shows Earth as huge, continents sprawling across the page, oceans vast and blue, countries colored and labeled as if they're meaningful chunks of space. Google Earth lets you zoom in on cities, streets, individual buildings. It reinforces the illusion that Earth is massive, detailed, important. And in your daily life, you can't walk around Earth. You can't even see the curvature. The horizon is always flat. The ground extends in every direction. It feels infinite, but it's not. Earth is 12,742 kilometers in diameter, about 40,075 kilometers around the equator. If you walked non-stop at 5 kilometers per hour, it would take you 334 days to circle the planet. Almost a year of continuous walking. That sounds big, right? A year of walking? But compared to what's out there, compared to the solar system, the galaxy, the universe, Earth is so small that calling it a speck would be generous. It's more like a grain of sand on a beach. No, smaller than that. A single atom in a grain of sand on a beach. And your brain doesn't want to accept this. It resists this information, because accepting it means accepting your own insignificance. And humans don't like feeling insignificant. But we're going to do it anyway, because the truth is more interesting than the comfortable lie. So let's start building scale. Step by step, comparison by comparison. Starting with something you can visualize, Earth compared to other planets. Here's how this journey works. we're going to zoom out in stages, 6 stages to be exact. Stage 1. Earth compared to other planets in our solar system. This is still manageable. You can visualize planets. You've seen pictures. This won't hurt too much. Stage 2. Earth compared to the Sun. This is where things start to get uncomfortable. The Sun is vastly larger than any planet. Earth becomes tiny. Your first ego hit. Stage 3. The solar system compared to other stars. Some stars are so large that millions of Earths could fit inside them. Your sense of scale will start breaking here. Stage 4. The solar system compared to the galaxy. This is where comprehension begins to fail. The Milky Way contains hundreds of billions of stars. The solar system becomes invisible. Earth becomes less than microscopic. Stage 5. The galaxy compared to the universe. This is total ego dissolution. Trillions of galaxies, septillions of stars. Numbers so large they become meaningless. Earth disappears entirely. Stage 6. What this means for you. The redemption, the meaning, the reason this matters. Each step will make Earth smaller. Each comparison will feel impossible. Each number will exceed what your brain can process. And somewhere around stage 4, probably when we reach the galaxy, your mind will just give up. The numbers will stop meaning anything. You'll read trillions and quadrillions, and your brain will just label them very big without actually comprehending the magnitude. That's normal. That's expected. That's everyone's experience with cosmic scale. But I want you to stay with me anyway, because even though you can't visualize these scales, you can feel them. You can sense the weight of them. You can let them change your perspective. And that's what this is really about. Changing perspective. Seeing Earth and yourself differently. So here's the challenge. Don't shut down when the numbers get too big. Don't tune out when your intuition fails. Lean into the incomprehensibility. Embrace it. Let it dissolve your comfortable assumptions about size and significance. Because on the other side of that dissolution, there's something profound waiting. Are you ready? Let's start with Earth itself, the planet you think you know. Earth, the planet you live on, the world that contains everything you've ever known. How big is it really? Most people couldn't tell you. They know it's big, in some vague sense. They know you can't walk across it in a day. They know it contains oceans and continents. But actual size, actual measurements, most people have no idea. So let's establish the baseline. Let's see what Earth actually is before we start comparing it to things that will make it vanish. Earth is 12,742 kilometers in diameter. If you measure from the North Pole to the South Pole, that's how far you'd travel. The circumference, the distance around the equator, is 40,075 kilometers. The surface area is 510 million square kilometers. That includes land and oceans. About 29% land, 71% water. The volume, the total amount of space Earth occupies, is about 1 trillion cubic kilometers. These numbers probably don't mean much to you. They're just abstract quantities. Large numbers without context. So let's add context. Let's compare Earth to other things you might have a reference for. If you drove around Earth's equator at highway speed, 100 kilometers per hour, it would take you 400 hours. That's 16.7 days of continuous driving. If you flew around the equator in a commercial jet at 900 kilometers per hour, it would take 44.5 hours, almost 2 full days. If you walked around the equator at 5 kilometers per hour, non-stop, no breaks, it would take 8,015 hours. That's 334 days, almost a full year. Earth is big enough. that walking around it would consume a year of your life. That feels significant, right? Important. Substantial. Hold that feeling, because we're about to start shrinking Earth. First stop, other planets. How does Earth compare to its neighbors in the solar system? Let's find out. Let's see how Earth stacks up against its planetary neighbors. We'll start with the planets smaller than Earth, then work our way up to the giants. Mercury, the smallest planet in our solar system. Diameter, 4,879 kilometers. That's 38% of Earth's diameter. Mercury is so small that if Earth were a basketball, Mercury would be a tennis ball. You could fit 18 Mercuries inside Earth's volume. Mars, the red planet. Diameter, 6,779 kilometers. That's 53% of Earth's diameter, about half. Mars feels significant in our culture. We talk about colonizing it. We send rovers there. We make movies about it. But it's small. You could fit 7 Mars-sized planets inside Earth. If Earth is a basketball, Mars is a softball. Venus, Earth's twin. Diameter, 12,104 kilometers. That's 95% of Earth's diameter. Venus is almost exactly Earth's size. If you saw them side by side, you'd barely notice the difference. But Venus is still slightly smaller, about 86% of Earth's volume. So Earth is the 5th largest planet in our solar system. Not the biggest. Not even close. Now, let's look at the giants. Neptune. Diameter, 49,244 kilometers. That's 3.9 times Earth's diameter. Neptune is so large that you could fit 58 Earths inside it. If Earth is a basketball, Neptune is a large exercise ball, about 1.3 meters across. Uranus. Diameter, 50,724 kilometers. That's 4 times Earth's diameter. Uranus is slightly larger than Neptune. You could fit 63 Earths inside Uranus. Same scale as Neptune, a massive sphere compared to our tiny planet. Saturn. Diameter, 116,464 kilometers. That's 9.4 times Earth's diameter. Saturn is enormous. Those beautiful rings, they span a distance wider than the gap between Earth and the Moon. The planet itself could hold 764 Earths inside its volume. If Earth is a basketball, Saturn is a small car, about 3 meters across. You couldn't fit it through a doorway, but Saturn isn't even the largest planet in our solar system. Jupiter. Diameter, 139,820 kilometers. That's 11 times Earth's diameter. Jupiter is a monster. The Great Red Spot, that storm on Jupiter's surface, is larger than Earth. The storm is bigger than our entire planet. You could fit 1,321 Earths inside Jupiter's volume. Let me repeat that. 1,321 Earths. If you hollowed out Jupiter and started filling it with Earth-sized planets, you'd need over 1,300 of them. If you lined up Earths across Jupiter's diameter, it would take 11 Earths to span from one side to the other. If Earth is a basketball, Jupiter is a sphere 3.6 meters in diameter, bigger than a car. You'd need a truck to transport it. Jupiter contains more mass than all other planets in the solar system combined. It's 318 times more massive than Earth. Earth, compared to Jupiter, is tiny, insignificant, a marble next to a beach ball. And you might be thinking, okay, Jupiter is big, but Earth is still a planet. That's something, right? Sure, Earth is a planet, one of 8 in our solar system. But now, let's compare Earth to the Sun, the star at the center of our solar system. the object that contains 99.86% of all the mass in the solar system. This is where things get uncomfortable. The Sun's diameter is 1,392,000 kilometers. Earth's diameter is 12,742 kilometers. The Sun is 109 times wider than Earth. If you lined up Earths across the Sun's diameter, you'd need 109 of them, stretching from one edge to the other. But diameter doesn't capture the true scale. Let's talk about volume. Volume scales with the cube of the radius. So when something is 109 times wider, it's 109 cubed equals 1.3 million times larger in volume. 1.3 million Earths fit inside the Sun. Let me give you a visual for that number. Imagine you have a giant, empty sphere the size of the Sun. You start filling it with Earths, not side by side on the surface. Filling it, packing Earths into the volume like marbles in a jar. You'd need to place 1.3 million Earths inside before you filled the Sun completely. If you added 1 Earth per second, it would take you 15 days of continuous placement to fill the Sun. Here's another way to visualize it. If Earth is a marble, 1 centimeter in diameter, the Sun would be a sphere 109 centimeters across. That's 1.09 meters, about 3.6 feet, taller than a small child, as wide as your arm span. You'd need 1.3 million marbles to fill that sphere. Now let's talk about mass. The Sun's mass is 1.989 times 10 to the 30th power kilograms. Earth's mass is 5.972 times 10 to the 24th power kilograms. The Sun is 333,000 times more massive than Earth. The Sun contains 99.86% of all the mass in the solar system. Jupiter, that giant we just talked about, contains most of the remaining 0.14%. All the other planets combined, including Earth, make up a tiny fraction of a percent. Earth's contribution to the solar system's total mass? 0.0003%, 3/10,000ths of 1%. Let that sink in. Everything you've ever known, every mountain, every ocean, every building, every person who has ever lived, every atom on Earth's surface and in its core. All of that represents 0.0003% of the solar system's mass. If the solar system were a pie, Earth would be a crumb so small you couldn't see it. But wait, it gets worse. Because the solar system isn't just the Sun and planets, it's mostly space. And when we zoom out to see the solar system's true scale, Earth becomes even more insignificant. Let's talk about distance. Earth orbits the Sun at an average distance of 150 million kilometers. This distance is called 1 astronomical unit, 1 AU. It's our baseline for measuring distances in the solar system. Neptune, the farthest major planet, orbits at 30 astronomical units. That's 4.5 billion kilometers from the Sun. So the solar system, from Sun to Neptune, spans about 60 astronomical units in diameter, 30 astronomical units in each direction from the Sun. That's 9 billion kilometers. But that's not even close to the solar system's true edge. Beyond Neptune lies the Kuiper Belt, a region of icy objects extending to about 50 astronomical units. Pluto orbits here. Beyond that is the scattered disk, extending to about 100 astronomical units. And beyond that is the Oort cloud, a vast spherical shell of comets and icy debris surrounding the entire solar system. The Oort cloud extends from about 2,000 astronomical units to 100,000 astronomical units from the Sun. 100,000 astronomical units, that's 15 trillion kilometers, about 1.6 light years. That's the solar system's true edge. That's where the sun's gravitational influence ends and interstellar space begins. Now let's scale this down to something you can visualize. Imagine the sun is a basketball, 24 centimeters in diameter. On that scale, Earth would be a tiny sphere 2.2 millimeters across, about the size of a peppercorn, and it would be located 26 meters away from the basketball sun. Jupiter would be 2.4 centimeters, a large marble, located 135 meters away. Neptune would be 8.6 millimeters, a small bead, located 780 meters away, almost half a mile from the sun. And Proxima Centauri, the nearest star, would be 6,800 kilometers away, the distance from New York to London. On a scale where the sun is a basketball, the nearest star is an ocean away. The solar system is 99.9999% empty space, vast, cold, dark, silent. And Earth is a peppercorn 26 meters from a basketball, floating in an emptiness so profound that the nearest other object, the nearest star, is on another continent. Do you see now? Earth isn't big. Earth is infinitesimally small, a speck in a void, orbiting a star that itself is tiny compared to what's out there. But we're just getting started, because now we need to leave the solar system. We need to see what happens when we compare our solar system, this vast 1.6 light-year wide region, to the galaxy. And that's where your sense of scale will truly begin to break. You've just seen Earth shrink from planet to peppercorn, from substantial to invisible. The sun, containing 1.3 million Earths, became a basketball. And even that basketball, with all its massive volume, is just one star among hundreds of billions. Now we zoom out further, to the Milky Way galaxy, our cosmic island, the structure that contains our solar system and 300 billion other star systems. And when we make this leap, from solar system to galaxy, something breaks. Some fundamental intuition about space and size just fails, because the numbers stop being numbers. They become abstractions, symbols, words that mean incomprehensibly large without conveying any actual sense of scale. But we're going to try anyway, because you need to see this. You need to feel Earth's insignificance at galactic scales. Even if your brain can't process it, your perspective can absorb it. Let's enter the Milky Way. Before we zoom out to the galaxy, let's establish one more critical comparison. Earth versus the distance between stars. We've talked about the solar system's size, 1.6 light-years from Sun to Oort cloud edge. That seems enormous. It is enormous on human scales. But the nearest star, Proxima Centauri, is 4.24 light-years away. That's 2.6 times farther than the solar system's edge. The gap between stars is larger than the solar system itself. Let me put this in perspective. If you could travel at the speed of light, the absolute maximum speed allowed by physics, it would take you 8 minutes to reach the Sun from Earth, 4 hours to reach Neptune, 1.6 years to reach the edge of the solar system, Oort cloud, 4.24 years to reach the nearest star. Even at light speed, impossibly fast, 299,792 kilometers per second. Crossing from our solar system to the nearest star takes over 4 years, and that's the nearest star. Most stars are hundreds or thousands of light years apart. The Milky Way galaxy is 100,000 light years across. It would take light 100,000 years to cross from one edge to the other. Our Sun is located about 26,000 light years from the galactic center. We're out in the suburbs of the galaxy, in a minor spiral arm called the Orion Arm. Now here's the scale comparison that will break your brain. If the Milky Way galaxy were the size of the United States, about 4,500 kilometers from coast to coast, the entire solar system would be the size of a quarter, a coin, 24 millimeters across. And Earth? On that scale, Earth would be smaller than a speck of dust on that quarter, invisible to the naked eye. You'd need a microscope to see it. The solar system, our entire cosmic neighborhood, this vast region spanning 1.6 light years, is a coin in a galaxy the size of a continent. And Earth is invisible dust on that coin. This is where we are. This is our place in the galaxy. Invisible, microscopic, irrelevant at galactic scales. But let's make it worse. Let's talk about the stars in our galaxy. Because some of them are so large that they make our Sun, and by extension, Earth, look like quantum particles. The Milky Way galaxy is 100,000 light years in diameter. Let me break that down. Light traveling at 299,792 kilometers per second would take 100,000 years to cross from one edge of our galaxy to the other. 100,000 years ago, humans were just leaving Africa. We were hunter-gatherers. We hadn't invented agriculture. We hadn't built cities. We hadn't developed writing. We were barely recognizable as the species we'd become. If light started crossing the Milky Way back then, it would arrive at the other side today, right now. That's the scale we're talking about. The Milky Way contains between 200 and 400 billion stars. Let's use a conservative estimate, 300 billion stars. Our Sun, the massive object that contains 1.3 million Earths, is one star among 300 billion. If you could somehow count one star per second, 24 hours a day, it would take you 9,500 years to count all the stars in the Milky Way. Our solar system is located about 26,000 light-years from the galactic center. We orbit the center once every 225 million years. The last time our solar system was in this exact position, dinosaurs were thriving on Earth. T-Rex hadn't evolved yet. We're moving through the galaxy at about 220 kilometers per second, fast enough to circle Earth in 3 minutes, and yet, at that incredible speed, it takes us 225 million years to complete one orbit. The galaxy is vast beyond human comprehension. Now let's try to visualize Earth's place in it. I told you earlier, if the Milky Way were the size of the United States, 4,500 kilometers across, the solar system would be the size of a quarter. Let's extend that analogy. The United States has about 330 million people. Imagine each person represents a star. Our Sun is one person among 330 million. Just one face in that massive crowd. And Earth? Earth is smaller than a single cell in one of those people. Invisible, microscopic, utterly insignificant. Here's another way to think about it. The Milky Way's volume is approximately 8 trillion cubic light-years. The solar system's volume, out to the Oort cloud, is approximately 33 cubic light-years. The Milky Way is 240 billion times larger in volume than our solar system. And Earth occupies 1 trillionth of the solar system's volume. So Earth occupies about 1 in 240 trillion of the galaxy's volume. Your brain cannot process this number. It's too small. It rounds to 0. It becomes meaningless. But that's the point. Earth, at galactic scales, is meaningless. It's a rounding error, a statistical noise, a speck so small it doesn't register. From the galactic center, 26,000 light-years away, Earth is invisible, undetectable. You could point the most powerful telescope in the universe at our solar system from the galactic core, and you wouldn't see Earth. You'd barely see the Sun. We are invisible. But wait, it gets worse. Because the Sun, already tiny, is actually a small star compared to some of the giants in our galaxy. Let's look at stars that make our Sun look microscopic. The Sun is classified as a G-type main sequence star, a yellow dwarf. It's medium-sized, average, unremarkable. Diameter, 1.4 million kilometers, but there are stars much larger. Sirius, the brightest star in our night sky. Diameter, 2.4 million kilometers, 1.7 times the Sun's diameter. You could fit 3.8 million Earths inside Sirius, still manageable, still within the realm of comprehension. But let's go bigger. Pollux, an orange giant star. Diameter, 12.6 million kilometers, 9 times the Sun's diameter. Volume, 729 times the Sun. You could fit 950 million Earths inside Pollux. If Earth is a marble, Pollux is a hot air balloon 30 meters across. Arcturus, a red giant, diameter, 36.4 million kilometers, 26 times the Sun's diameter. You could fit 19 million Earths inside Arcturus. Aldebaran, another red giant in the constellation Taurus. Diameter, 61.4 million kilometers, 44 times the Sun's diameter. You could fit 87 million Earths inside Aldebaran. If you placed Aldebaran where the Sun is, its surface would extend past Mercury's orbit. It would swallow Mercury whole. But we're just getting started. Betelgeuse, the red supergiant in Orion's shoulder, one of the most famous stars in the night sky. Diameter, approximately 980 million kilometers, 700 times the Sun's diameter. You could fit 343 billion Earths inside Betelgeuse. 343 billion. Not million. Billion. If you placed Betelgeuse where our Sun is, its surface would extend beyond Mars's orbit. It would swallow Mercury, Venus, Earth, and Mars. All 4 inner planets would be inside the star. If Earth is a marble, 1 centimeter across, Betelgeuse would be a sphere 700 centimeters in diameter. That's 7 meters across, bigger than a room. You couldn't fit it inside a house. But Betelgeuse isn't even close to the largest star we've discovered, Antares, a red supergiant in Scorpius. Diameter, 1.1 billion kilometers, about 800 times the Sun's diameter. You could fit 512 billion Earths inside Antares. Vue Canis Majoris, one of the largest known stars in our galaxy, a red hypergiant. Diameter, approximately 2 billion kilometers, 1,420 times the Sun's diameter. You could fit 2.86 trillion Earths inside Vue Canis Majoris. 2 trillion, 860 billion Earths. If Earth is a marble, Vue Canis Majoris is a sphere 14.2 meters in diameter. You could fit a 2-story house inside it. If you placed Vue Canis Majoris where our Sun is, its surface would extend past Saturn's orbit. It would swallow Mercury, Venus, Earth, Mars, Jupiter, and Saturn. 6 planets. Gone. Inside the star. Light would take 6.5 hours to travel around Vue Canis Majoris' circumference. 6.5 hours at light speed just to circle the star once. And here's what's devastating. Stars like Vue Canis Majoris exist. They're rare. Most stars are small, dim red dwarfs, but they're real. They're out there in our galaxy, and compared to them, Earth is less than atomic, less than subatomic. It's a quantum fluctuation, a rounding error in a rounding error. You could fit nearly 3 trillion Earths inside one star. Let that destroy your sense of scale completely. Let's do some math. Painful, brain-breaking math. The Milky Way contains approximately 300 billion stars. Most stars are smaller than the Sun. Red dwarfs, brown dwarfs. But let's be conservative and assume the average star has the same volume as our Sun. Our Sun can hold 1.3 million Earths. So, 300 billion stars times 1.3 million Earths per star equals 390 quadrillion Earths. 390 quadrillion. Earth volumes could fit in the stellar volume of the Milky Way. And we're not even counting the space between stars. The Milky Way's total volume, including all the empty space, all the voids, all the dark matter, is about 8 trillion cubic light years. 1 light year is 9.46 trillion kilometers. Earth's diameter is 12,742 kilometers. If you wanted to fill the Milky Way's volume with Earths, pack them in like marbles in a jar, how many would you need? The math is complex, but the answer is approximately 10 to the 30th power Earths, about 1 nonillion Earths. Your brain has stopped processing these numbers. They've become meaningless. Just words, symbols that represent incomprehensibly large. And that's okay. That's expected. Because you cannot comprehend a nonillion of anything. It's beyond human cognitive capacity. But here's what you can grasp. Earth is one planet, one single world. And you could fit a nonillion copies of it in the Milky Way's volume. Earth is nothing at galactic scales, less than nothing. An infinitesimal speck in an ocean of space. And the Milky Way? It's just one galaxy among trillions. But we're not there yet. First, let's see what Earth looks like from different perspectives within our own galaxy. Imagine you're an alien astronomer on a planet orbiting a star on the other side of the Milky Way. You're 100,000 light years away from Earth. On the opposite edge of the galaxy, you point your telescope toward our region of space. What do you see? Nothing. You can't see Earth. You can't see the solar system. You can barely see our Sun, and only because it's a star, a point of light among billions of other points. Earth? Earth is invisible, utterly, completely undetectable. Even if you had a telescope powerful enough to resolve planets, which would require technology far beyond anything we can imagine, Earth would still be lost in the glare of the Sun. From across the galaxy, we are invisible. Now imagine you're an alien on a planet, orbiting a star 1,000 light years away from Earth. Much closer, in our galactic neighborhood. You point your telescope at our solar system. What do you see? Maybe, you see the Sun, a faint yellow star among thousands of others in that patch of sky. But Earth, still invisible, still undetectable, still lost in the light of its parent star. You'd need a telescope so powerful, so impossibly advanced, that you could block out the Sun's light and image the planets directly. And even then, Earth would be a tiny dot, a single pixel, barely distinguishable from Venus or Mars. From 1,000 light years away, a distance that's tiny on galactic scales, Earth is effectively invisible. And from Andromeda, our nearest major galaxy, 2.5 million light years away, Earth doesn't exist. The solar system doesn't exist. You can barely resolve individual stars. The Milky Way is just a faint smudge, a spiral structure of light. Earth is not just small, it's invisible, undetectable, lost in the cosmic vastness. We are utterly, completely alone in the dark. But here's the thing. The Milky Way is just one galaxy, one island of stars in a universe containing trillions of galaxies. And now, we're going to zoom out to that scale. To the scale of galaxy clusters, superclusters, and the observable universe. And this is where your sense of scale won't just break. It will shatter completely. Are you ready? You've just seen Earth disappear. It became invisible against the backdrop of the galaxy. A planet so small that from across the Milky Way, our own galaxy, it cannot be detected. The Sun, containing 1.3 million Earths, became one star among 300 billion. Unremarkable, average, forgettable. And now we leave the Milky Way. We zoom out to see our galaxy as one object among many. We enter the realm of galaxy clusters, superclusters, the large-scale structure of the universe. And at this scale, the Milky Way itself, this massive spiral containing hundreds of billions of stars, becomes a speck. Earth ceases to have any meaning at all. It's not just invisible, it's conceptually irrelevant, too small to matter, too insignificant to register. But we're going to look anyway, because you need to see this. You need to feel the full weight of cosmic scale. You need to understand that Earth is not just small. It's so small that the word small doesn't capture it. Let's zoom out to the universe. The Milky Way isn't alone. It's part of a small cluster of galaxies called the local group. The local group contains approximately 80 galaxies, though the exact number keeps changing as we discover more dwarf galaxies hiding in the cosmic void. The local group is about 10 million light-years in diameter. The two dominant galaxies are the Milky Way, our home, 100,000 light-years across, 300 billion stars, Andromeda, M31, our nearest major galactic neighbor, 220,000 light-years across, about 1 trillion stars. The third largest is the Triangulum Galaxy, M33, about 60,000 light-years across, with roughly 40 billion stars. The rest are dwarf galaxies, small, faint, containing millions or billions of stars instead of hundreds of billions. The large and small Magellanic Clouds, visible from the southern hemisphere, are examples. They orbit the Milky Way like moons orbit a planet. So, the local group, 80 galaxies in a region 10 million light-years across. Now let's place the Milky Way in that context. The Milky Way is one of 80 galaxies, one of two major galaxies. It represents maybe 15 to 20% of the local group's total mass. The rest is in Andromeda and smaller galaxies. If the local group were a city with 80 buildings, the Milky Way would be one of the two tallest skyscrapers, impressive within its local context. And Earth? If the Milky Way is a skyscraper in that city, Earth is a single atom somewhere in one room on one floor of that building. Invisible, irrelevant, microscopic beyond comprehension. But the local group, this cluster of 80 galaxies, is just one cluster. It's a tiny, insignificant structure in the cosmic web, because the local group is part of something much, much larger. In 2014, astronomers mapped the motion of galaxies in our cosmic neighborhood. They traced how galaxies move, not just away from each other due to cosmic expansion, but toward gravitational centers. And they discovered something profound. The local group, along with thousands of other galaxy clusters, is part of a massive structure called the Laniakea supercluster. Laniakea is Hawaiian for immeasurable heaven. The name fits. Laniakea is 520 million light-years in diameter. It contains approximately 100,000 galaxies. Let me repeat that. 100,000 galaxies. The Milky Way, our home, containing 300 billion stars, is one galaxy among 100,000. The Milky Way represents 0.001% of Laniakea's galaxies, 1,000,000%. If Laniakea were a nation of 100,000 cities, the Milky Way would be one city, not the capital, not anything special, just one city among 100,000. And Earth? Earth is one atom in one building in that one city. Let's try to visualize Laniakea's scale. If Laniakea were a sphere 520 meters in diameter, About the length of 5 football fields, the Milky Way would be 0.52 millimeters across, half a millimeter, smaller than a grain of sand, barely visible to the naked eye. You cannot see Earth at Laniakea scales. You cannot even see the Milky Way without magnification. We have become less than microscopic. Laniakea contains structures like the Virgo cluster, 1,500 galaxies in a region 65 million light-years across. The Hydra Centaurus, supercluster, thousands of galaxies including the Great Attractor, a gravitational anomaly pulling the Milky Way and thousands of other galaxies toward it. The Coma cluster, over 1,000 galaxies in a region 20 million light-years across. Each of these structures contains more galaxies than the local group, and they're all just small parts of Laniakea. The total mass of Laniakea is approximately 10 to the 17th power solar masses. That's 100 quadrillion times the mass of our Sun. The Milky Way's mass is about 1.5 trillion solar masses, so Laniakea is roughly 67,000 times more massive than the Milky Way, and the Milky Way is 333,000 times more massive than Earth. Multiply those. Laniakea is 22 billion times more massive than Earth. You are standing on a planet that represents 4.5 billionths of 1% of your supercluster's mass. And Laniakea? It's just one supercluster among millions. Now we zoom out to the largest scale we can observe, the observable universe. The observable universe is 93 billion light-years in diameter. It contains approximately 2 trillion galaxies. The Milky Way is one galaxy among 2 trillion. The Milky Way represents 500 millionths of 1% of all galaxies in the observable universe. 500 millionths of 1%. If you picked a random galaxy from the observable universe, the chance of picking the Milky Way is 1 in 2 trillion. And those 2 trillion galaxies contain approximately 1 septillion stars. Our Sun is one star among 1 septillion. Each of those stars, on average, is similar to or larger than our Sun, so each could hold roughly 1 million Earths. That means the stellar volume of the observable universe could hold approximately 10 to the 24th stars, x 1.3 million, Earths per star, boxes 1.3 times 10 to the 30th Earths, 1 nonillion, 300 octillion Earths. But that's just the volume of stars. The universe is mostly empty space. If you wanted to fill the entire observable universe, all 93 billion light-years of it, with Earths packed side by side, you'd need approximately 10 to the 84th Earths. That's 1 followed by 84 zeros. A number so large it doesn't have a common name. Mathematicians just call it 10 to the 84th. For comparison, there are approximately 10 to the 80th atoms in the observable universe. You would need 10,000 times more Earths than there are atoms in the entire cosmos to fill the observable universe's volume. Your brain stopped trying to comprehend this several paragraphs ago. The numbers have become meaningless, just large abstract quantities that signify bigger than I can imagine. And that's the point. Earth's smallness compared to the universe cannot be visualized. It can only be stated, acknowledged, accepted. But let me try one more analogy, one more comparison that might help you feel, even if you can't comprehend, the scale we're talking about. You've heard this comparison before. There are more stars in the universe than grains of sand on all of Earth's beaches. Let's check if that's true. Estimated number of grains of sand on all of Earth's beaches, deserts, and sandy surfaces. Approximately 7.5 times 10 to the 18th. That's 7.5 quintillion grains of sand. Number of stars in the observable universe, 10 to the 24th. 1 septillion stars. Ratio 10 to the 24th divided by 7.5 times 10 to the 18th equals 1.3 million. There are 1.3 million times more stars in the observable universe than grains of sand on Earth. Let that sink in. For every grain of sand on every beach, in every desert, on the entire planet, there are 1.3 million stars in the universe. If you held a single grain of sand in your hand, that grain represents one star, and there are 1.3 million more stars for that single grain. Now think about Earth. Earth is the planet that contains all those beaches, all that sand, every grain. And in the universe, there are potentially trillions of planets. Earth is one planet among trillions, orbiting one star among septillions, in one galaxy among trillions. Earth, the container of all that sand, is less significant to the universe than a single grain of sand is to Earth. Let me say that again. Earth's significance to the universe is less than one grain of sand's significance to Earth. You could remove one grain of sand from a beach and nothing would change. The beach would look the same, function the same, be the same. That's Earth's cosmic significance. Removable without consequence, invisible without magnification, irrelevant at universal scales. But wait, it gets worse. Because the observable universe, the 93 billion light-year sphere containing 2 trillion galaxies, might be just a tiny fraction of the total universe. The observable universe is the region from which light has had time to reach us since the Big Bang 13.8 billion years ago. But the total universe, the full extent of all space and matter, is almost certainly larger, possibly much larger, possibly infinite. We can't see beyond the observable boundary because light from those regions hasn't reached us yet. And due to the accelerating expansion of space, it might never reach us. But we can make estimates based on cosmological models. Conservative calculations suggest the total universe is at least 250 times larger than the observable universe in each direction. If that's true, the total universe would be about 23 trillion light-years in diameter. The observable universe, 93 billion light-years, would represent about 0.4% of the total volume, less than half of 1%. Everything we can see, every galaxy, every star, every structure, is less than 0.4% of what exists, and in that 0.4%, Earth is invisible. So in the total universe, Earth is invisible within invisible, insignificant within insignificant, a speck within a speck within a speck. And if some cosmological models are correct, the universe might be infinite, truly without boundary, extending forever in all directions. In an infinite universe, there would be infinite galaxies, infinite stars, infinite planets, and Earth would be one finite planet in an infinite cosmos. Its share of space, 1 divided by infinity, which equals 0. In an infinite universe, Earth mathematically occupies 0% of space. We are nothing, less than nothing, an infinitesimal point in an endless expanse. But here's the strange thing, the thing that will eventually redeem this journey, Earth being. This small doesn't make it meaningless. It makes it rare, precious, extraordinary, because while the universe is vast, most of it is empty, dead, unconscious, and Earth, tiny, invisible Earth, is alive, conscious, aware. But we'll get to that later. First, we need to confront one more layer of incomprehensibility. We need to talk about what happens when analogies completely fail, when visualization becomes impossible, when numbers stop being numbers and become pure abstraction. We need to see what lies beyond the mathematics. You've just watched Earth vanish, not metaphorically, mathematically, observationally, literally. the Milky Way became a grain of sand in Laniakea. Laniakea became invisible in the observable universe, and the observable universe might be 0.4% of the total. Earth is less than a pixel on your screen, less than an atom in the cosmic structure, less than anything you can visualize or comprehend, and your brain has given up. It stopped trying to grasp these scales somewhere around Act 3, maybe when we reach the galaxy, maybe when we hit superclusters, but definitely by now. The numbers are too big, the ratios too extreme, the comparisons too abstract, and that's okay, because we're about to shift gears. We're going to stop trying to make you visualize Earth's smallness and instead help you understand what it means. What does it mean to be this small? What happens when analogies fail? How do we make sense of our place in something this vast? Let's find out. Let's be honest about what just happened. Somewhere in the last 10 minutes, your brain stopped processing the information. The numbers became too large, the ratios too extreme, the comparisons too abstract. You read 2 trillion galaxies, and your brain labeled it very big, without actually comprehending what 2 trillion means. You heard 10 to the 24th stars, and the notation became meaningless. Just symbols on a screen. Mathematical shorthand for incomprehensibly large. You saw 1 grain of sand compared to Earth's cosmic significance, and maybe, you felt something, but you didn't truly grasp it. This isn't your fault. This is how human brains work. We evolved to understand the scale of our immediate environment. Meters, kilometers. Maybe thousands of kilometers if we're being generous. We can visualize a room, a building, a city, maybe even a country if we've traveled enough. But we cannot visualize a galaxy. We cannot comprehend a supercluster. We cannot grasp the observable universe. Every analogy breaks down. Every comparison fails. If Earth were a marble, works until you reach stars like Betelgeuse, where Earth becomes smaller than an atom in your analogy. If the universe were there's nothing to compare it to. It's all of space, the container that holds everything else. There's no external reference point. Earth is like 1 grain of sand on a beach. Except Earth is smaller than that. So you try, Earth is like 1 atom in a grain of sand, but even that fails at larger scales. The analogies collapse under the weight of cosmic scale. And that's okay. You don't need to visualize Earth's smallness. You just need to accept it. Accept that Earth is so small compared to the universe that the comparison becomes meaningless. That the ratio approaches 0. That our planet is, for all practical purposes at universal scales, non-existent. But here's what's interesting. There's a perspective from which Earth isn't small. A reference frame where the entire universe, all 93 billion light-years of it, is infinitesimally tiny. And that perspective belongs to light itself. Let me take you back to special relativity, Einstein's revolution. Time and space are not absolute. They're relative. They depend on your velocity, how fast you're moving. As you approach the speed of light, time slows down. Distances contract. Reality itself becomes malleable. At exactly the speed of light, 299,792 kilometers per second, time stops completely, and distances shrink to 0. This is what photons experience, particles of light. They travel at light speed by definition. From a photon's perspective, no time passes during its journey, and no distance is crossed. A photon emitted from a star in Andromeda, 2.5 million light-years away, experiences its journey like this. Emission and absorption happen in the same instant. Zero time elapsed, zero distance traveled. From our perspective, that photon traveled for 2.5 million years across 23.7 quintillion kilometers. From the photon's perspective, the star in Andromeda and your eye are at the same point in space-time. They're touching. The distance between them is zero. Now scale this up to the observable universe. From our slow, massive perspective, the universe is 93 billion light-years across, incomprehensibly vast. From a photon's perspective, traveling at light speed, the entire observable universe has zero size. Every point in space is touching every other point. The Big Bang and the present moment are simultaneous. The whole universe is compressed into a single point. Both perspectives are true. Both describe the same reality from different reference frames. So here's the paradox. Earth is simultaneously incomprehensibly small from our massive, slow perspective, and the same size as the entire universe from light's perspective. Scale is relative. It depends on your reference frame, your velocity, your perspective. And if scale is relative, then maybe smallness isn't an absolute property. Maybe it's just how things appear from our particular viewpoint. This doesn't make Earth bigger, but it does make size more complicated than we thought. Let's shift perspective again. Let's zoom in instead of out. Your body contains approximately 7 times 10 to the power of 27 atoms. 7 octillion atoms. 7 billion billion atoms. That's an incomprehensibly large number. You cannot visualize 7 octillion of anything. Each atom is about 10 to the power of negative 10 meters across. 1 10,000,000,000th of a meter. If you magnified an atom to the size of a marble, 1 centimeter, you would be 100 million times larger. You'd be 170 million meters tall, tall enough to see from space, tall enough to be visible from the moon. From an atom's perspective, if atoms had perspective, you are incomprehensibly vast, impossibly large, a structure so big it cannot be comprehended at atomic scales, just as you relate to the galaxy. Let me show you the parallel. You compared to an atom. You're about 10 to the power of 10 times larger than an atom, 10 billion times. You contain 10 to the power of 27 atoms. The Milky Way compared to you. The Milky Way is about 10 to the power of 21 meters across. You're about 1.7 meters tall. The galaxy is 10 to the power of 21 times larger than you, 1 billion trillion times. The galaxy contains 10 to the power of 30 Earth volumes worth of space. The scale difference between you and an atom is similar to the scale difference between a galaxy and you. You are vast to an atom. The galaxy is vast to you. It's the same kind of ratio, the same kind of incomprehensibility. And here's the profound implication. Atoms don't know you exist. They can't perceive you. They're too small. They operate at scales where you, as a unified being, don't have meaning. Similarly, the galaxy doesn't know you exist. At galactic scales, you're too small to register. You operate at scales where individual organisms don't matter. But here's the twist. You exist anyway. You're conscious anyway. You matter to yourself, to other humans, to Earth's ecosystem, regardless of whether galaxies can perceive you. And atoms, they exist. They matter to chemistry, to biology, to you, regardless of whether you can perceive individual atoms. Scale works both ways. You're simultaneously vast compared to atoms, and tiny compared to galaxies. You're in the middle, larger than some things, smaller than others. Neither the smallest nor the largest structure in existence. And that position, that middle ground, is actually significant. Here's the paradox we've been building toward. Earth is invisibly, incomprehensibly, insignificantly small compared to the universe. And yet, Earth contains you, a conscious being capable of comprehending the universe. Most of the universe is empty, void, vacuum, space containing nothing but occasional photons and hydrogen atoms. Most of the matter in the universe is unconscious, stars burning through fusion, gas clouds collapsing, black holes consuming, galaxies colliding, all of it following physical laws, cause and effect, matter interacting with matter, energy flowing from high to low entropy. None of it aware, none of it thinking, none of it caring. It just exists, mechanically, deterministically, without purpose or meaning or consciousness. But Earth, tiny Earth, invisible Earth, insignificant Earth, is alive. Earth contains billions of living organisms, complex ecosystems, biospheres that have existed for billions of years. And Earth contains consciousness, beings that can observe, think, wonder, comprehend. You are one of those beings, and as far as we know, consciousness is rare in the universe, vanishingly rare. We've discovered over 5,000 exoplanets, planets orbiting other stars, and we haven't found life on any of them yet. We haven't detected any signals, any evidence of other technological civilizations. Maybe life is common and we just haven't found it yet. Maybe the universe is teeming with consciousness and we're looking in the wrong places or wrong ways. Or maybe, life is extremely rare. Maybe the conditions required for consciousness are so specific, so unlikely, that most galaxies contain zero intelligent species. Maybe we're genuinely alone, or nearly alone. We don't know. But the evidence suggests life is not abundant. It's not everywhere. It's special. And that makes Earth, despite its size, significant. Because Earth isn't just matter. It's matter that's organized, complex, aware. The universe is vast, but vastness without consciousness is just empty space and dead matter. Earth is tiny, but Earth is alive. And that aliveness, that consciousness, is what gives the universe meaning. Without observers, the universe exists, but it's meaningless. Galaxies form and collide, and nobody's watching. Stars explode and nobody notices. The cosmos unfolds according to physical laws, and nobody cares. But with observers, with consciousness, the universe becomes meaningful. It becomes beautiful, awe-inspiring, worth contemplating. You, tiny, finite, fragile you, are the part of the universe that's awake. And that's not insignificant. That's extraordinary. Smallness doesn't equal meaninglessness. Size doesn't equal significance. Earth is small. You're small. But you're also rare, precious, conscious. And that changes everything. We've zoomed out from Earth to planets, to the sun, to stars, to the galaxy, to superclusters, to the observable universe. And at each step, Earth became smaller, less significant, more invisible. By now, you should feel cosmically humbled, small, unimportant. But here's the twist, the redemption, the meaning, the reason this journey was worth taking. Being small doesn't make you meaningless. It makes you rare. The universe is vast, yes, but most of it is dead, empty, unconscious. Earth, tiny Earth, is alive. And you, tinier still, are conscious, aware, capable of comprehending bigness. And that's what we're going to explore now. In the final act, the payoff, the reason smallness actually matters. We're going to talk about what Earth's smallness means. Not scientifically, we've covered that, but personally, philosophically, existentially. Why does it matter that you're tiny? What do you do with this knowledge? How does cosmic scale change your perspective on life? Let's bring this home. On February 14th, 1990, the Voyager 1 spacecraft, then about 6 billion kilometers from Earth, beyond the orbit of Neptune, turned its camera around and took one final photograph of home. Earth appeared as a tiny point of light, less than a single pixel, a pale blue dot suspended in a sunbeam. Astronomer Carl Sagan, who suggested taking the photo, later wrote about it. "Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. Every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam." That photograph was taken from 6 billion kilometers away. Not 6 billion light years. Just 6 billion kilometers, barely beyond Neptune. A tiny distance on cosmic scales. And from that distance, Earth was already invisible, a fraction of a pixel, barely distinguishable from the noise in the camera. From 6 billion kilometers, a distance light crosses in 5.5 hours, Earth disappeared. Now imagine viewing Earth from the galactic center, 26,000 light-years away. Earth wouldn't just be invisible. It would be completely, utterly undetectable, lost in the glare of the sun, which itself would be a faint point among billions. From Andromeda, 2.5 million light-years away, the sun would be invisible. The solar system wouldn't exist as far as any observer could tell. We are profoundly, cosmically alone, isolated on a speck of dust in an ocean of void. And Sagan's words capture why this matters. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. We are small. Earth is small. And nobody's coming to save us. Nobody's watching. Nobody cares except US. And that realization, that isolation, is both humbling and liberating. So what does Earth's smallness teach us? What wisdom can we extract from cosmic scale? Lesson 1. Perspective on problems. Your daily worries, your job stress, your relationship conflicts, your financial anxieties are microscopic on cosmic scales. This doesn't make them meaningless to you. Your problems are real. They affect your life, your happiness, your well-being. But understanding Earth's smallness offers relief. Your problems, however overwhelming they feel, are confined to a tiny planet in a vast cosmos. They're local, temporary, finite. 1,000 years from now, nobody will remember your embarrassing moment, your failed project, your argument with a friend. The universe will continue. Stars will burn. Galaxies will collide. And your problems will have vanished into cosmic irrelevance. This isn't depressing. It's freeing. It gives you permission to take things less seriously, to worry less, to accept that most of what stresses you doesn't matter at cosmic scales. Lesson 2. Unity. All of humanity, every person who has ever lived, exists on this tiny planet. We're all sharing this speck of dust together. Our divisions, national borders, ethnic conflicts, religious disputes, are absurd given our shared smallness. We're dividing a grain of sand and fighting over which part belongs to whom. We're drawing lines on a pixel and claiming ownership. From space, there are no borders, no nations, no divisions, just one planet, one humanity, one shared home. Earth's smallness should unite us. We're all in this together, isolated on a fragile world in an indifferent cosmos. Lesson 3. Preciousness. Earth is small, but Earth is also rare. We've discovered thousands of exoplanets. Most are hostile. Too hot, too cold, too massive, no atmosphere, bathed in radiation. Earth-like planets, rocky worlds in the habitable zone with liquid water, are uncommon. Not impossible, but not everywhere. And Earth with life, with complex ecosystems, with intelligent technological civilization, that might be vanishingly rare. We don't know yet, but the evidence suggests we shouldn't assume life is common. Earth might be one of a handful of living worlds in the entire galaxy, maybe one of a few thousand in the observable universe, or maybe we're alone. Genuinely, completely, terrifyingly alone. Either way, Earth is precious. Not because it's large, but because it's alive. We should protect it, preserve it, not take it for granted. Because if we lose Earth, if we render it uninhabitable through war, pollution, climate change, there's nowhere else to go. No backup planet, no escape. This is it. This tiny, fragile, beautiful speck is our only home. Lesson 4. Humility. We are not the center of the universe. The cosmos doesn't revolve around us. We're not special by virtue of size or position. We're one species on one planet, orbiting one star in one galaxy among trillions. This cosmic humility is healthy. It counteracts human arrogance. It reminds us that we're part of something larger, not the masters of it. The universe existed for 13.8 billion years before humans appeared. It will exist for trillions more after we're gone. We're temporary, brief, a blip in cosmic time. And accepting that, truly accepting our insignificance, makes us kinder, humbler, more grateful. Lesson 5. Wonder, despite being small, we can comprehend bigness. Despite being brief, we can understand deep time. Despite being confined to one planet, we can study the entire universe. This is extraordinary. Miraculous even. You, made of stardust, living for decades, confined to Earth, can understand that the observable universe is 93 billion light years across, can grasp that there are more stars than grains of sand, can contemplate your own insignificance. The universe created consciousness, and that consciousness can understand the universe that created it. You're tiny, but you're also aware. And that awareness is the universe's way of knowing itself. That's profound. That's beautiful. That's worth celebrating. Let's address the cognitive dissonance directly. You're cosmically insignificant. Your planet is invisible at universal scales. Your existence barely registers. And yet, you matter. You're important. Your life has meaning. Both of these statements are true. How? Because significance isn't about size, it's about consciousness. A galaxy is vast, billions of stars, trillions of planets, quadrillions of tons of matter. But as far as we know, galaxies aren't conscious. They don't think. They don't feel. They don't wonder. They don't create meaning. They just exist, mechanically, deterministically, following the laws of physics without purpose or intention. But you're conscious. You think, you feel, you experience. You create meaning. And that makes you rare. Most of the universe is dead matter. Hydrogen gas, helium, dark matter, dark energy, radiation, all of it unconscious. All of it just following physical laws. But you're alive. You're aware. You're the part of the universe that can look back at itself and understand what it is. Carl Sagan said it perfectly. We are a way for the cosmos to know itself. The universe, vast, ancient, mostly empty, created you, a conscious being capable of comprehending the universe's scale. And that's extraordinary. You're not significant because you're large. You're significant because you're conscious. Size doesn't matter. Awareness does. A star might be 1,000,000 times larger than Earth, but as far as we know, stars aren't aware. They don't appreciate their own existence. They don't create art, science, philosophy, meaning. You do. And that makes you, tiny, brief you, more significant than a star. Not in mass, not in energy, not in volume, but in meaning. Because meaning requires consciousness, and consciousness is rare. You matter because you're awake, because you can think, because you can comprehend. Earth is small. You're smaller, but you're the part that knows. And that knowing, that consciousness, is what gives the universe purpose. Without you, without consciousness, the universe is just matter and energy interacting. Stars burning, galaxies colliding, entropy increasing. With you, the universe becomes meaningful, beautiful, worth experiencing. You're tiny, but you're also the part that makes existence matter. And that's everything. So what do you do with this knowledge? How do you live differently, knowing Earth is this small? Knowing you're this insignificant? First, embrace cosmic humility. Your ego is not the center of reality. Your concerns, while valid, are local and temporary. The universe doesn't care about your promotion, your relationship drama, your social media following. Let that be liberating, not depressing. You can take yourself less seriously. Worry less about what others think. Forgive yourself more easily. You're cosmically insignificant. So am I. So is everyone. That levels the playing field. Nobody's more cosmically important than anyone else. Second, appreciate Earth. This tiny planet is your only home. There's no backup, no escape, no planet B. Take care of it. Protect its ecosystems, preserve its beauty, fight climate change, reduce pollution, conserve resources. Not because Earth is cosmically important, it's not, but because it's your home, and it's rare, and it's precious. Third, value connection. Every human shares this speck. We're all together on this grain of sand, floating through the void. Our divisions, race, nationality, religion, politics, are absurd given our shared smallness. We should cooperate, not conflict. Unite, not divide. From space, there are no borders, only one planet, one humanity, one fragile home. Fourth, pursue meaning. Since the universe doesn't provide inherent meaning, you must create it. Create significance through consciousness, not size. Through awareness, not mass. Love deeply. Create beauty. Pursue knowledge. Help others. Experience joy. These things don't matter to the universe, but they matter to you, and that's enough. Meaning doesn't come from being large. It comes from being alive, from being conscious, from choosing to care. Fifth, look up. Regularly. Often. Whenever you feel overwhelmed or self-important or lost. Go outside. Find a dark place. Look at the stars. Remember where you are. Remember how small you are. Remember that you're part of something vast, ancient, magnificent. Let the stars humble you. Let them remind you that your problems are temporary, that your time is brief, that this moment, right now, is precious because it's fleeting. Earth is small, you're small, but you're here. You're alive. You're aware. And for this brief cosmic moment, that's enough. Let's end where we began, with numbers, with scale, with one final comparison. Earth's diameter, 12,742 kilometers. Observable universe's diameter, 93 billion light-years. Let's convert that to kilometers. 880 sextillion kilometers. That is, 880 followed by 21 zeros. That's 880 sextillion kilometers. The ratio. The observable universe is 69 billion trillion times wider than Earth. 69 sextillion times wider. If Earth were 1 millimeter, the thickness of a credit card, the observable universe would be 69 trillion kilometers across. That's 460 times the distance from Earth to the Sun. You cannot visualize this. Don't try. Just accept it. Earth is unimaginably, incomprehensibly, impossibly small compared to the universe. And you, living on it, walking across its surface, breathing its air, you're even smaller. You're one organism among billions, one body among 8 billion humans, one human among countless living things. You occupy maybe 0.1 cubic meters of space for maybe 80 years on a planet that's 12,742 kilometers across, in a universe that's 93 billion light-years across. Your spatial significance, negligible. Your temporal significance, negligible. Your mass, negligible. By every objective measure, you don't matter. You're too small, too brief, too insignificant. And yet, you're the part of the universe that's conscious, that knows, that comprehends. You're the part that can look at the stars and understand what they are, that can measure cosmic distances, that can grasp, however dimly, the scale of existence. The universe is measured in billions of light-years. You're measured in decades. The universe contains septillions of stars. You contain septillions of atoms. The universe is vast and mostly dead. You're tiny and alive. Both are true. Both matter. Earth is unimaginably small, but Earth is also the stage on which your life unfolds. Your experiences, your relationships, your meaning. And that meaning, personal, local, temporary, is real, valid, significant, not to the universe, but to you. And you're the one who's conscious, so your perspective matters most. You're small. Earth is small. Accept it, embrace it, let it humble you, but don't let it diminish you, because smallness isn't the same as meaninglessness. You're tiny, but you're also cosmic, made of stardust, conscious, aware, alive. And for this brief moment, this fleeting instant in cosmic time, you get to experience the universe. You get to look up at the stars and feel wonder. You get to love and learn and create and discover. You get to know that you're small. And that knowing, that consciousness, is the most extraordinary thing in the universe. Earth is small. You're small. But you're the part of the universe that can comprehend bigness. And that's everything. We've journeyed from Earth 12,742 kilometers across to the observable universe, 93 billion light-years across. We've watched Earth shrink at every step, compared to planets, to the Sun, to giant stars, to the galaxy, to superclusters, to the cosmos itself. We've confronted ratios that break comprehension, numbers that become meaningless, scales that our brains cannot process. And we've arrived at the truth. Earth is invisibly, incomprehensibly, insignificantly small. Not metaphorically, mathematically. Earth occupies essentially 0% of the universe's volume, contains essentially 0% of its mass, exists for essentially 0% of cosmic time. We are nothing. Less than a pixel. Less than an atom. Less than anything we can visualize. And yet, we're also everything that matters. Because we're conscious. We're aware. We're the part of the universe that knows. If this changed your perspective, if you feel simultaneously humbled and elevated, subscribe. There's more cosmic perspective to explore, more impossible scales to confront, more ways to see yourself differently. Comment below. Which comparison hit you hardest? When did your brain give up? Jupiter, 1,321 Earths. The Sun, 1.3 million Earths. Betelgeuse, 343 billion Earths. The galaxy? The universe? Tell me where comprehension broke. Share this video with someone who needs cosmic humility, someone who feels too important or not important enough, someone who needs to remember that we're all sharing this tiny grain of sand together. And tonight, absolutely, go outside and look up. Find the stars. Find the Milky Way if you're away from city lights. Find Andromeda if you can. That faint smudge 2.5 million light years away. And remember, you're standing on a planet that's invisible from that galaxy. A planet so small it doesn't register at cosmic scales. But you're also standing on the only planet that we know of, where conscious beings can look at Andromeda and understand what it is. You're tiny. Earth is tiny, but you're the part that's awake, the part that knows. And that knowing, that consciousness, is the universe's greatest achievement. Look up tonight. Remember how small you are, and let that smallness make you grateful.